Good morning everyone. Once again welcome back to our class. Now we are going to discuss about the kinematic equations of motions. Four equations now we were discuss about the only for three questions. V is equal to u plus half it square, s is equal to u plus half it square, v square minus u square is equal to 2as. These three questions from using graphical method. For using graphical method and also this equations for using Neet and JEE Mains. Okay, first of all, here chapter is motion in a straight line. Okay, the graphical treatment, the kinematic equations of motions for a body, the body moving with uniform acceleration. Now here see here motion in a straight line. Topic here motion in a straight line, graphical treatment, the kinematic equations of motion of a body with uniform acceleration. Now the body is starting from initial velocity u to reach the point, for example at any point after some time t. The final velocity here, for example v, the body moving with uniform acceleration a. So graphical method graphical method ఉపయోగించి ఏం చేస్తున్నామంటే మనం the velocity time graph, velocity time gives displacement and acceleration. Okay, now first of all see here, this is a x axis, this one here x axis. Okay, now this one here, this is y axis. The time taken as x axis, the velocity of the body taken as here y axis. Okay, this one here time, this is a velocity. Okay, velocity taken as y axis. O is a here origin, the particle moving with initial velocity u, the particle moving with here initial velocity u. Okay, after some seconds or after some time to reach the point b, for example to reach the point here b. Okay, final velocity here v, initial velocity for example u. Now the velocity taken as y axis, the time taken as x axis. Now velocity time graph, this one here final velocity, this one here initial velocity, this is a parallel to the x axis, this is here change in velocity, this one here change in velocity. Okay, a b, for example this one a b c d, this is a graph. Here slope ab is a slope, this ab is a slope that is equal to tan theta, this is a theta, this one here theta. Okay, the slope or ab line gives here uniform acceleration of the particle, అంటే ఇక్కడ ab అనేది దేని తెలియస్తుందంటే ఇక్కడ uniform acceleration of the particle. So under that is equal to here, first of all show that here s is equal to u plus half t square, v is equal to u plus half v is equal to u plus at, v square minus u square is equal to 2as. First of all to show that v is equal to u plus at, first equation, this is a kinematic first equation, so that the v is equal to u plus at. Now in this graph, from the graph ab is a slope, that is gives the acceleration of the particle, now here slope here show that v is equal to u plus at. Okay, here slope is equal to tan theta is equal to a, so a is equal to opposite sides here, tan theta is equal to here bc by ac, here bc nothing but change in velocity, here ac nothing but here time, here it is a time, so velocity time graph, here a velocity, here slope is the slope of velocity time graph gives the యాక్సలరేషన్ ఆఫ్ ద పార్టికల్, యూనిఫామ్ యాక్సలరేషన్ ఆఫ్ ద పార్టికల్. అంటే ఇక్కడ వెలాసిటీ టైం గ్రాఫ్ యొక్క తీసుకున్నట్టయితే ఈ స్లోప్ అనేది దేని తెలియజేస్తుందంటే ఆ వస్తువు పొందినటువంటి యూనిఫామ్ యాక్సలరేషన్ సూచిస్తుంది. సో స్లోప్ ఈజ్ ఈక్వల్ టు tan θ ఈజ్ ఈక్వల్ టు A ఈజ్ ఈక్వల్ టు BC బై AC. సో here BC ఈజ్ ఈక్వల్ టు V minus U by here AC is equal to time. AC is equal to here time. Okay. Now simplifies here tan theta is equal to A is equal to V minus U by T. V minus U by T. So simplifies here, that is here A is equal to AT is equal to V minus U. Simplifies V is equal to U plus AT. This is the equation of first kinematic equation of the motion of the body. So A is a uniform acceleration, T is a time, U is a initial velocity, and V is a final velocity of the particle. Okay, this is the T. Now here tan theta is equal to V minus U by T. Tan theta is equal to here V minus U by T. This is the equation, first equation of the kinematic equation of first motion. Okay, next one, to show that S is equal to UT plus from graphical method. Here from graphical method, first of all note this one first of all. Okay, slope is equal to tan theta is equal to A is equal to BC by AC. Here BC nothing but change in velocity, final velocity minus initial velocity by time. So tan theta is equal to V minus U by T, and V is equal to U plus AT. Okay, velocity time graph, velocity time positive x-axis, okay. Now next one, S is equal to UT plus half AT square. Next one, S is equal to UT plus half AT square. Show that here, to show that here S is equal to UT plus half AT square, Now here in this graph, the particle moving with uniform acceleration A, initial velocity U, here final velocity T after time T, after some seconds here T. Okay, here the slope of the AB, the slope of the line AB under the area of velocity time graph, under the area of velocity time graph along x-axis, along positive x-axis, gives the displacement of the particle, ఇక్కడ ఏంటంటే here AB is a slope or line, straight line. Okay, this is a straight line under the AB line, from velocity time graph, positive x-axis gives the displacement of the particle, అంటే ఇక్కడ AB అనే లైన్ యొక్క కింద ఉన్నటువంటి ఏరియా అనేది ఆ వస్తువు పొందినటువంటి స్థాన ప్రమిషాన్ని సూచిస్తుంది. ఓకే, నౌ here from graph here AC is equal to, and here OD is equal to simply time T. Okay, next OA is equal to CD is equal to here U. Next BC is equal to simply here change in velocity. So this is now here AB slope, here under the AB slope gives the area under the AB slope gives the displacement of the particle. So AB is a displacement under this area is gives this displacement. Now here simply, very simple, this diagram velocity time graph here, these two parts here, in this one 2 parts. Okay, this is a 2 parts here, one is a rectangle, another one is here triangle. So now this one, displacement of the particle here, displacement of the particle S is equal to the area under the AB slope, the area under the AB slope, velocity time graph along x positive x axis. Okay, here the displacement of the particle S is equal to the area rectangle, the area of rectangle OACD. Okay, rectangle area, rectangle plus here the area of triangle ABC, and area here, area of triangle here, triangle means here ABC here, rectangle here OACD. Okay, this is a rectangle, area of the rectangle plus area of the triangle. This is gives here displacement of the particle along the slope AB. Now this values here substituting, this place implies here S is equal to rectangle nothing but here OA. Okay, OA into here OD here plus area of the triangle nothing but half into base into height. Here base means AC, base here into base into here height, base into height. Now OA is equal to here, OA is equal to U. Okay, OA is equal to here just U into OD. Here OD nothing but OD is nothing but here time plus of here base nothing but here T, base nothing but here this is a base. Okay, base. Okay, base is here T into height, here height nothing but here triangle BC nothing but here V minus U. Okay, now simplifies UT plus of T into here V into V minus U. But here VD is equal to U plus AT, but V is equal to final velocity is equal to initial velocity plus AT. A is a uniform acceleration, nothing but constant acceleration. Now V minus U is equal to simply here AT. V minus U is equal to bust here AT. Now simplifies one step here UT plus of T into this is equal to here AT. This is equal to here. So half into T into AT, that is T into T square, T into T here T square. So the displacement of the particle moving with the uniform acceleration S is equal to UT plus here half into AT square, half into here AT square. This is a second equation of kinematics, second kinematic equation of the particle, This is a second kinematic equation of the particle. Next one, V square minus U square is equal to 2AS. Next one here, V square minus U square is equal to 2AS. This equation here gives here general process, general method. General we will get here now general method. Okay, this one here graphical method, this one here graphical method. Okay, now general method, know this one first of all. So the displacement of particle is equal to, this is a straight line nothing but AC. So the area under the AC, the area under the AB is equal to the displacement of the particle, the S is equal to, so area of the triangle plus area of the rectangle. So thus values here substituting after, finally V is equal to S is equal to U plus UT plus of AT square. Now know this one first of all. Next one, general methods. Okay, again here general method S is equal to UT plus of AT square and V square minus U square is equal to 2AS. Now here this one here general method, method to show here, show that here s is equal to ut plus of at square okay. First of all, when a particle is moving with uniform acceleration a, then the average velocity here, when a particle is moving with uniform acceleration a, now the average velocity then n is average velocity here, average velocity here avg is equal to initial velocity plus your final velocity by 2, initial velocity by final velocity by 2. This is the average velocity of the particle. Now when a particle moving with uniform acceleration along the straight line, for example, or any dimensions, now the average velocity of the particle vag is equal to u plus v by 2. Here v means final velocity, u means here initial velocity, okay. The displacement of the particle here, now displacement of the particle here, s is equal to average velocity into time. Now displacement s is equal to, simply displacement s is equal to here average velocity is nothing but here u plus v by 2, okay, and time here t, okay. But here v is equal to, from first equation of the kinematic equation, first kinematic equation, v is equal to u plus here at. Now in this equation the terminate the final velocity, that means here v is equal to u plus at. So this v values here substituting here, after we will get here the displacement of the particle. Now since here v is equal to u plus at, this is a first kinematic equation, so simply s is equal to u plus, here v means u plus at by 2 into here t into t. Now here u plus u, 2u, that is equal to 2u plus here at by 2 into t. Simplies here displacement s is equal to this t multiplication inside, so here t into 2u, okay, 2ut plus by 2, this is a denominator 2, plus here at into t, at square by 2, so in the here this equation 2 get cancelled, here get cancelled, simplies here s is equal to remaining terms ut plus here of at square. This is a general method, this one here general method. For example, when a particle is moving with uniform acceleration a, hence or average velocity is equal to final velocity plus initial velocity by 2, the displacement of the particle s is equal to average velocity into time, so average velocity here substituting t is equal to, so this equation terminate the final velocity, so v is equal to u plus at, so v values here substituting, after finally we get a final velocity displacement of the particle s is equal to ut plus of at square. This is a general method, okay. Next general method, v square minus u square is equal to 2as, v square minus u square is equal to 2as. Note this one first of all, okay. Simply show that same b square minus here b square minus u square is equal to 2as. So when a particle is moving with uniform acceleration a. So average velocity this one here. So displacement of the particle s is equal to u plus v by 2 into t. But here, the terminate the time here, terminate the time t from this equation. ఈ సమీకరణం నుండి t అనే టర్మ్స్ తొలగించాలి. సో అకార్డింగ్ టు the first equation of the motion, here v is equal to u plus at. U plus at. So simplifies v minus u is equal to at. So here t is equal to v minus u by a. This is a information. Okay, time t is equal to v minus u by a. Okay, v minus u by a. So this t values here substituting in this equation. So t value substituting in this equation here simplies here s is equal to u plus v by 2 into t values here, this is a v minus u by a. So denominator here a and 2, so that is equal to here simplies here s is equal to u plus v into v minus u by 2 into a 2a 2 into a 2a. So simplies here s is equal to a plus b into a minus b formula. Here a plus b into here a minus b formula is equal to a square minus here b square, a square minus here b square. So according this equation compared to that formula, here s is equal to simplies s is equal to b square minus u square by here 2a. So is equal to here s is equal to, so v square minus u square is equal to finally here 2as. This is a third kinematic equation of particle. So the particle moving with uniform acceleration. These equations only for the applicable the particle moving uniform acceleration. So v square minus u square is equal to 2as. This is a third equation of the kinematic equation. ఇది మనకు చలన సమీకరణంలో మూడవ చలన సమీకరణం. Now finally Sn is equal to u plus a into n minus 1 by 2. So this one, next note this one first of all. Here simply displacement is equal to average velocity into time. So finally t is equal to v minus u. This value is here substituting. After we will get finally v square minus u square is equal to 2as. Okay, next one v square minus, okay, next Sn is equal to u plus a into n minus 1 by 2. How to this formula, how to we will get this formula? Show that here show that to show that here Sn is equal to u plus a into n minus 1 by 2 or here Sn is equal to u plus a by 2 into 2n minus 1. Show that this equation. Now first of all, the particle moving along the straight line with uniform acceleration a, initial velocity u, the displacement of the particle here is s. So according to second equation here, s is equal to ut plus half at square. This is the particle moving along the straight line with constant or uniform acceleration a. Okay, initial velocity u, the time taken to the after some time here t. This is a second equation of motion. Now the particle moving along the straight line n seconds. So that means here the particle moving along the straight line n seconds. Okay, here for example this is a straight line, for example this one here straight line. Okay, this is a particle p is a, for example, particle moving along the straight line. Okay, here time taken t. So initial velocity u, here final velocity for example v, uniform acceleration a, So here t is equal to n seconds. This particle moving along the straight line n seconds. So n seconds, so the displacement of the n seconds, displacement of the particle in n seconds. Here now displacement of particle in n seconds, here Sn is equal to, okay, Sn is equal to n seconds, okay, n second, Sn is equal to here un plus 1 by 2 an square, okay. Next, the particle moving along the straight line n minus 1 seconds, the displacement of the particle in n minus 1 seconds. So next one, this is the first one, this is the second, displacement of particle in n minus 1 seconds, n minus 1 seconds, okay. Here Sn minus 1 is equal to u into n minus 1, okay, plus 1 by 2 a into n minus 1 square. This one here n seconds, this one here u n minus 1 seconds displacement. Sn seconds displacement, here Sn minus 1 displacement. Now nth seconds, we want to, here nth seconds is equal to, here the displacement of the particle in n seconds minus the displacement of the particle in n minus 1 seconds, that is equal to Sn seconds, okay. Nth seconds here, Sn seconds here, nth seconds here, that is equal to here Sn is equal to n seconds is, okay. Next Sn is equal to 1 ikkada endante displacement of particle in n seconds minus the displacement of particle in here n minus 1 seconds, seconds. So these values here substituting. So now nth seconds is equal to here Snth is equal to here Sn minus here Sn minus 1, Sn minus 1. Now Sn is equal to this value here, Sn minus 1 is equal to this equation. So these two equations from nth seconds here, nth seconds is equal to here un plus of an square. This is a Sn seconds, this one here Sn seconds, minus Sn 1 seconds, this one here u here into u into n minus 1 plus 1 by 2 into n minus 1 square, okay. ఇక్కడ ఏం లేదు, this is a Sn minus seconds, this one here Sn seconds, displacement of the Sn seconds. So this one is simplified. After simplifying, we will get to finally here Sn is equal to Sn seconds is equal to u plus a by 2 into 2n minus 1, okay. Here simplifies. Note this one first of all. Now okay, S is equal to here Sn is equal to simplifies here simplifies now simplifies Sn is equal to here, this is this one un plus of an square minus this inside multiplication un plus into minus u, okay, plus now of into this a minus b formula, a minus b whole square formula. A square means here n square plus 1 square minus 2n. Okay, this is a n minus 1 square formula. So simplifying, n square plus 1 square plus minus 2n 1. Okay, now simplies un plus 1 by 2 a n square. Here this is a inside one step, un minus u plus into minus plus into plus. So okay, plus of n square by 2 of n square by 2. Next plus into plus 1 plus. Okay, a by 2 into n. So a by 2 n. Okay, plus into minus minus. So here minus a by 2 into 2n. So a by 2 into 2n. Here one term 2 get cancel. Here 2 get cancel. Any terms cancel. Now simplies. Here Sn is equal to un plus 1 by 2 n square. Inside open this bracket, minus into plus minus. Okay, minus un. Next minus into minus plus. Okay, this one here u. Next minus into plus minus. Okay, this one a n square by 2, a n square by 2. Next minus into plus minus. Okay, a by 2. Next minus into minus plus. Okay, this one here remaining an, remaining here an. Now then in this sequence terms here, in this terms some terms here cancel terms. Now plus un here, this one here plus un, here minus un, this cancel. This is a cancel, once cancel. Okay, next plus of n square, plus of n a n square. Okay, minus here of a n square. So this term also cancel, this terms also cancel. Now remaining terms here, remaining terms Sn is equal to remaining, this is a u, this one here u plus u minus a by 2 plus here an plus here an. So in this one a is a common term, a is a common term. So simplies here u, a is a common plus a common. So this is positive values, this one here negative values. So n minus here 1 by 2, n minus n. This is a equation of Sn seconds. Sn, the displacement of the particle in Sn seconds, nth seconds. Sn is equal to u plus u plus a into n minus 1 by 2 or here or Sn is equal to simply u plus here of common a by 2 into 2n minus 1. This is the displacement of the particle in Sn seconds. Nth seconds, Sn is equal to u plus of a by 2 into 2n minus 1 or Sn is equal to u plus a into n minus 1 by 2. This is a nth seconds. Okay, next one, the kinematic equations in method of calculus, method of here calculus, that means a integration method. First of all, note this one. Okay, to obtain, note this one first of all, to obtain equation of motion, to obtain equation of motion for constant acceleration, okay. Now integration methods are calculus. Here simply to obtain equations of motion, to obtain equation of motion for constant acceleration, for constant acceleration acceleration using method of calculation. ఇంకా method of calculus. Okay, method of calculus. సో ఇక్కడ మనం క్యాలిక్యులేషన్ ప్రాసెస్ ఉపయోగించి the equation of motions, out of we will get this three equations. V is equal to u plus at, v square minus u square is equal to as, and s is equal to ut plus half at square. Okay, now first of all equations. Okay, first equation show that here, first equation show that first one, v is equal to here u plus at, u plus here at. Now here equation, the acceleration statement, the rate of change of velocity is called as a acceleration. According to acceleration formula, now here acceleration a is equal to dv by dt. This is the rate of change of velocity, that is equal to acceleration. So simplifies here, dv is equal to here dv is equal to dt. This equation integrating on both sides, here time intervals 0 to t, here velocity, change in velocity, initial velocity to final velocity, here final velocity. So this equation, now above equation integrating both sides, okay, integrating on both sides here, integrating upper limit here v, here lower limit here just to v naught. So dv is equal to here upper limit to t, here lower limit here 0, here a t. Okay, now this is a simplifies upper limit minus lower limit. So v upper limit v, here lower limit here v naught, that is equal to here a is a constant, so dt, this is a just one dt, sorry, dt a is a constant, so just to t, upper limit here t and lower limit here 0, upper limit minus here lower limit, minus here lower limit, that is equal to v minus here v naught. V means the initial velocity, v naught means the initial velocity, v means final velocity of the particle. Okay, is equal to a into here upper limit to t, here lower limit here 0. Simplifies here, this is simplifies v minus v naught is equal to at. So at, so simplifies here v is equal to v naught plus at, here at. This is a calculation method, integrating method. So v is equal to v naught plus at. Here v naught means initial velocity of the particle, a means uniform acceleration, here t time or seconds, in seconds, here v final velocity. This is a first equation. Next one, s is equal to ut plus half at square. Next one here, s is equal to ut plus half at square. Okay, show that here. Next one, show that s is equal to, note this one first of all, s is equal to ut plus half at square, or ఇందులో కొన్ని చేంజ్ చేసే టర్మ్స్. ఓకే, నోట్ దిస్ వన్ ఫస్ట్ ఆఫ్ ఆల్. నౌ velocity is equal to the rate of change of displacement is called as here simply velocity. So velocity, here velocity is equal to dx by dt. Now this equation here, v dt is equal to just to dx, but here v is equal to v naught plus here at, here v V is equal to V naught plus AT. This is the first equation of the kinematic equation. First kinematic equation, V is equal to V naught plus AT. So this one here substituting simply, okay, V naught plus AT and dt is equal to dx. This equation integrating on both sides. This equation integrating on both sides. Okay, this equation integrating here, integrating both sides. Now simplifies here upper limit in this one here, upper limit this t, okay, 0 upper limit to t, here lower limit here just to 0 naught, V naught plus here AT dt. Okay, here upper limit x here, lower limit x naught. This is the initial displacement here, this one final position, this one here initial position. So here dx, here formula x dx is equal to x squared by 2. X dx is equal to here just x squared by 2. That means here x power of n dx is equal to formula x power n plus here x power n plus 1 by n plus 1. ఇది ఫార్ములా ఉంటుంది మనకి, ఇంటిగ్రేషన్ ఫార్ములా వస్తుంది. ఓకే, నౌ దిస్ ఈజ్ సింప్లైజ్ హియర్ v naught t and here plus a t squared by 2. Here upper limit t, here lower limit here just to 0, lower limit here 0 is equal to simplifies, this is a just to dx nothing but just x. Okay, x, okay, upper limit x here, lower limit x naught, upper limit minus here lower limit. Simplifies, this is a t value substituting. First of all v naught t plus AT squared by 2 minus 0 here minus 0. Okay, minus is equal to here upper limit here x, here lower limit x naught, final position this one here initial position. X naught means here initial position, here x means here final position of the particle. Now simplifies this one here, simplifies remaining term, this is a these two 0. So v naught t plus AT squared by 2, AT squared by 2 is equal to x minus x naught. Simplifies here x is equal to x naught plus v naught t plus of AT squared. This is a second kinematic equation. The particle moving along the straight line any direction with uniform acceleration, or constant acceleration. So x naught means initial position, x means final position, v naught means initial velocity, and t time is a constant nothing but uniform acceleration. This is the second equation. Next, v square minus u square is equal to 2as. Okay, note this one. First of all, equation, kinematic equation, very simple. v is equal to dx by dt, cross multiplication just simply. So v is equal to value substituting, after we will get here finally x is equal to x naught plus v naught t plus of AT square. Now v square minus u square is equal to 2as formula. Here acceleration a is equal to simply dv by dt. A is a constant, here acceleration a is equal to dv by dt. So this equation multiply and divide with dx, that means here simply dv by dx into dx by dt. A is equal to dv by dt, that is equal to a is equal to dv by dx into dx by dt. So here dx by dt is equal to just v, velocity of the particle. Now here a is equal to simply v dv by dx, this is a dv, this one dv by dx. So simplifies a dx is equal to v dv. V dV. Now this equation integrating on both sides. This equation is integrating on both sides. Okay, both sides. Now here upper limit a integral x naught x dx is equal to here v integral v naught here v dv. Okay, v dv here formula x dx formula is equal to x power n plus 1 by n plus 1. Okay, here this is this formula. So here n is equal to just here 1, x is equal to here x means v, n is equal to just n is equal to here power of 1. That means integrating here just x upper limit x naught is equal to here v square by 2 upper limit v and lower limit v naught. So upper limit minus lower limit implies here a is a constant, Now here x minus x naught is equal to simply v square minus v naught squared by 2, v square minus v naught squared by 2. Now simplies x minus x naught is equal to, this is a cross multiplication, v square minus u square by 2, or this one here x is equal to x naught plus this is also a. Okay, v square minus u square v naught square by 2a just 2a. Okay, this is a equation. Or here v square minus v naught square is equal to here 2 into x minus x naught. This is also formula. This is a v square minus u square is equal to 2a's formula. This equations for using non-uniform acceleration. ఇక్కడ ఈ సమీకరణం మనము పార్టికల్ నాన్ యూనిఫామ్ యాక్సిలరేషన్ ఉన్నప్పుడు ఈ పార్టికల్ మనం యూజ్ చేసుకోవాలి. ఓకే, ఫైనల్లీ x is equal to x naught plus v square minus v naught square by 2a, or v square minus u square v naught square is equal to 2a into x minus x naught. ఈ x naught means initial position, x means final position, a acceleration, v naught means initial velocity, here v means final velocity of the equation. So these equations for using JEE Mains and Neet, and also MSET and etc. competitive exams. Okay, note this one first of all. Okay, thank you. Malli next class kladam. Thank you, all the best.